Hello 171 class, this is your notes for section 8.1. And in 8.1 we are doing solving systems of linear equations with a matrix, but instead of just doing it on your calculator like we did before, plugging in the systems into a matrix on the calculator like we have been, we're actually going to create them and solve them by hand. So you can actually see what's going on behind the scenes with your calculator. So before we had this system of equations, we typed in the coefficients here and the constants, and we used that REF to check our solutions. We're going to do the same thing, except we are actually going to create that REF or our REF, depending on which way we choose to solve it, form, but we're going to do it by hand. So the augmented matrix that you see here is what we've been doing to plug it into our calculator. It's just we have this extra line here, right, which is, it's not really there. It's not a big deal. You don't see it on your calculator. You don't have to have that in there when you make these. It's just something a lot of people use to show that separator of the coefficients and the constants. But it's something that we've already seen, that we've been using to check our solutions before. All right. Our goal when we solve these is to have ones on the main diagonal and then zeros either just below it like this, or in this case if you had zeros here, that would be REF if the main diagonal was ones and everything else on the left side of the line was zeros. Or this right here, this upper triangular form, if you want to call it that, it was called REF, where we have ones on the main diagonal, zeros below it, and then it's still fine if you have numbers above it. And in that case we could solve the equation. We have one variable solved for right here, z equals whatever this number is. And then we could plug in and figure out what y is, and then plug in and figure out what x is. But that's our goal, is to have ones on the main diagonal, zeros below it, and or zeros above it as well. It's easier work to just get zeros below. It's a little more work to get zeros above, but if you get the zeros above and below the main diagonal, then you have x, y, and z solved for, and you don't have to do any back substitution. Your calculator, when you have it in our REF mode, it was showing you the solutions. REF mode, which we haven't seen yet, is this mode where we have zeros below the main diagonal, but not necessarily above. So if I show you the reduced echelon form here of the matrix, I get, let me do math, fraction, I get z equals 5, and then I have more work to do to solve for y and x. But it does have the zeros below the main diagonal of ones. Okay, so that's REF, or row echelon form. Alright, now the way we're going to do this is by matrix operations. So these are the matrix row operations that we're allowed to do. We're allowed to take any two rows of a matrix and interchange them. So this means that I could take in my matrix B here, I could take this 3, 1, 2, 31 and take it from the top row and put it right here, 3, 1, 2, 31, and put the 1, 1, 2, 19 on the top. And it's still the exact same system. It's just we're being presented with the the system in a different order. Instead of top, middle, bottom, it's middle, top, bottom, but it's still the same three equations. So we're allowed to change any two rows in the system. All right, the elements in any row may be multiplied by a non-zero number, meaning we could multiply both sides of an equation by 2 or something, to get that like we do when we do the elimination process. And then the elements in each row can be multiplied by a number and then added to another row. So we do that again when we do the elimination method. So that's the idea. That's the matrix operations that we're allowed to do by a sequence of any of these events. All right, and then when we see the notation to do that, so interchange the elements, the ith and jth rows. So flip-flop those rows, like row 1, row 3. If I flip them, I would indicate it that way. Multiply each element in the ith row by this. So if this was a 2 right here, this I, and that was a negative 3 right here, the K, that means multiply the second row by -3. And then multiply and add. So multiply by the second row and add to the third row, something like that. So things that we've already done, we just are now going to have notation to tell you what to do, because it would just take a lot more space to write out each step. So we use this R subscript notation. Alright, so let's see if we can do this. So A says interchange row 1 and 2. So here's our matrix. We want to interchange rows 1 and 2. Alright, so I got it written down here. I'm going to take row 1, slide it down. I'm going to take row 2, slide it up. So there's row 1 and row 2 interchange. That's all it literally means. Just take the top row, put it in the middle, take the middle row, put it on the top, and that's your new matrix. So this would be row 1, row 2 swapped. Okay. B says 1/3 of row 1. So I'm going to take row 1, the 3, 18, the -12, and the 21. And all of them are going to multiply by a third. Same thing as dividing them by 3. And 3 divided by 3 is 1. 18 divided by 3 is 6. -12 divided by 3 is -4. 21 divided by 3 is 7. So I get 1, 6, -4, 7. And then notice the rest of the matrix just stays the way it is. So 1/3 row 1, I do that to the top row. But the other two rows stay exactly how they are, and they all have to be written in there for it to be that operation. I'm just doing it to one row, but the rest of the matrix is still there. Alright, then part C says take the second row, multiply it by 2, and add it to the third row. So I'm going to take this second row, I'm going to put over here, I'm going to multiply that row by 2, and then after I do that, I'm going to add the third row to that after I've doubled it. So the first thing we're going to do is double this top or the second row, and we're going to get 2, 4, -6, and 10. And now we're going to add these two rows together. 0, 1, -2, and 4. And now this row, this new row that we got when we do this operation, is going to replace the bottom row. Alright, so I pick it up and bring it over here. It has replaced the bottom row. When we do these operations, when we add a row to another row, whatever the second row is, like the one that comes after the plus sign, is the row that gets replaced. So after we double this row and add it to the other row, this now becomes the new row 3. It now becomes the new bottom row, and we replace that row with it. So this is our new matrix. Remember, when we do these row operations, the solution is a matrix. So the top row and the second row, the one that gets multiplied by a number and then added to another row, that row doesn't change. The first two rows here stay the same. It's the third row that follows the plus sign that gets replaced with what happens after we've done these row operations. Alright, now what we want to do with this, the reason why we're studying these row operations, is because we want to have ones everywhere on that main diagonal, and then we want to have zeros below it. But we have to do it in a particular order. We have to do the very first upper left corner needs to be a 1. And then after we've got a 1 there, then we get zeros below it using the properties that we just did here, the matrix row operations. Notice here, 2 times row 1 plus row 3 gets me a 0 right here. So that's the type of stuff that we're going to do to get zeros in these second positions. And then once we have that 1, 0, 0, then we move to this middle position right here, and we make sure that we get a 1 right there. And then once we have a 1 there, we want a 0 underneath it. Alright, and then finally, once we have the 0 there, 2 zeros here, 1s on the main diagonal, then we finally move to that last position and make it a 1. And then we have our 1s on the main diagonal, our zeros underneath it, and that's called the REF, or the row echelon form. Row echelon form, 1s on the main diagonal, zeros below it. Lower triangle is like 1s and zeros. The upper triangle has the numbers here in this coefficient side of the matrix. So that's our goal. And if you notice down here, it's 0 x's, 0 y's, 1 z equals a number. So we solve for z by creating this type of a matrix. So let's practice it. Let's take our matrix right here. Let's make an augmented form of the matrix, and then let's go through the row operations to get it into the row echelon form. Okay, so here is my initial matrix, just taking the coefficients and the constants and putting it into an augmented matrix form. Now remember, what is our first goal? Our first goal is to get a 1 in this upper left-hand corner. Now remember the things I'm allowed to do. I'm allowed to multiply this row by any number, or in multiply division, same thing. I could divide this row by 3 and I'd have a 1 there. Okay, but I'd also have a 1/3, a 2/3, and a 31/3. Alright, and that's not the prettiest thing in the world. But remember the other things you can do. You don't have to divide this by 3 to get a 1 there. You can also row swap. So I could actually take this middle row here and I could swap it with the top row. So I could put the second row on the top and the top row in the middle. Alright, so that could be my first step. I could say, alright, instead of dividing the top row by 3, I'm just going to move this up here. Now I still have whole numbers. You want to hold on to whole numbers as long as you can, just because you don't want to have to deal with fractions if you don't have to. So because dividing that top initial row by 3 created fractions, I just row swapped. And now I have 1, 1, 2, 19 on the top. It's just like I'm putting this as the first equation in this system of equations. It's still the same 3 equations. It's just now I have this one listed on the top because I want a 1 right there. Okay? And I got my 1 right there. I've accomplished the main goal of putting a 1 in that position. Alright, now what's the next goal? Zeros on the second and third row in this first position. So what I need to do here is to zero out this row, I have to multiply something by the top or bottom, but technically you do the top when you've got a 1 right here. But I'm going to multiply the top row by -3 and add it to the second row, and that will give me the 0 in that position. If I multiply here by -3, I get -3 plus 3 is 0, and I'll get to replace it on this middle row. And that's what I want to do. Alright, so what I want to do, -3 times row 1 plus row 2. I'm going to multiply these numbers times row 1 and add that to row 2. Now I'm going to show you how your calculator can help with this. On your calculator you can press second parentheses and it creates a little set bracket. And then you can type in this top row 1, 1, 2, 19. Alright. You can take that top row, and that's what we're going to multiply by -3. So times -3. So it's going to multiply those numbers times -3, and then plus, and then add the second row. So second parentheses again for that little set bracket. Type these numbers, always separated by comma. 3, 1, 2, 31. Alright, oops, and always close it with a set bracket. Alright, and then enter. And then there's what we would get if we did this. Now you can verify, you can multiply and check. -3 times 1 is -3 plus 3 is 0. -3 times 1 is -3 plus 1 is -2. -3 times 2 is -6. -6 plus 2 is -4. And then -3 times 19 is -57. -57 plus 31 is -26. So it works. It's just doing it for you. It's doing all that. But you have to use those set brackets that are above the parentheses. So that's going to be our new row 2. That's what we're going to replace row 2 with in this matrix. Alright, so I replaced the 0, -2, -4, -26 with where the old second row used to be. Okay, top row is still the same, bottom row is still the same, but that middle row is now what we get when we multiply the top row by -3 and add it to the second row. So that gives us a 0 right there. Now, next thing we want to do, we've got our 0 here. Next thing we want to do is get the 0 right here. Okay, right now we have a 1. So what we have to do now is multiply the top row again. We don't want to do the bottom row because we won't be able to get an opposite now because we've got a 0 there. Anything now times the middle row will give us 0. But the top row times -1 added to the bottom row will give me a 0 in that position. So -1 times row 1 plus row 3 this time. Okay, so there's the notation. What I do next, I'm going to bring this down. So I'm going to do -1 times row 1 plus row 3. So this was the last thing I did. Notice this is still row 1. So I'm going to hit second enter. There's row 1, 1, 1, 2, 19. Okay, that's still what I'm working on. I'm going to go back up here, change that to a -1 times that row, and then change this to the bottom row, 1, 3, 2, 25. So -1 times the first row plus the third row. I hit enter, and then I get this, 0, 2, 0, 6. 0, 2, 0, 6. Alright, so I've taken that 0, 2, 0, 6, put it on the bottom row again. I'm adding to row 3 this time, so it's replacing row 3. And we're starting from this matrix. Okay, I went from here to here, and now from here to here. So this is the matrix I'm building off of. I did this to the top row, added now to the third row, and now I've got the 1, 0, and the 0. Alright, so I've got this first whole step done. Now my next goal is to get a 1 here in the middle. So from our new matrix, I want a 1 right here. Alright, now I can divide this row by -2 and get a 1 right there. But because my next goal is a 0 right there, my next goal would be the 0 right there, it would be fine to go ahead and add rows 2 and 3 together and go ahead and get that 0 and then go back and divide this, since we already have that opposite. So even though technically going by the steps I should get a 1 right here, I'm going to go ahead and just use the fact that these are opposites as they are now, add these two rows together, add row 2 to row 3, and go ahead and get a 0 right there. I've got a blank down here now. When I'm adding these two rows together, I can go to my calculator and add them with the brackets, but you know, when you're adding just two rows, it's easy to do it just by sight. So I'm going to get a 0, a 0, a -4, and -26 plus 6 is -20. So 0, 0, -4, -20. Alright, so again, I've added those two rows together. This is my sum of row 2 plus row 3. And again, when you add two rows together, it's always the second row that's being replaced. So that row is being replaced. All right, and then there's that second row. Now, technically, again, I wanted a 1 right here. All right, so I'm going to multiply or divide, however you want to look at it, this middle row to get a 1 right here. So I'm going to divide the middle row by -2, or equivalent to multiplying it by -1/2. All right, so we got 1/2 row 2. Again, this previous matrix row 2 is what we have -1/2 of. So -1/2 times -2 is 1, -1/2 times -4 is 2, and then -1/2 times -26 is +13. So there's our new row that we get here. Again, the top row and the bottom row stay as the same as they were. And now if you look, we've got 1, 0, 0, 1, 0. We've got all this. So we're ready to do our last step. Our last step here is take care of this last piece right here. Get a 1 on this bottom right part of the diagonal. So we need to make a +1 right here. So we're going to divide this row by -4, or equivalently multiply by -1/4. Okay, and there is our final row operation. So if you look, now we've got everything we want. We've got 1s on the main diagonal, 0s everywhere below the main diagonal. Okay, this is the REF form of the matrix. 1s on the main diagonal, 0s everywhere below that. Okay, a lot of times this is called an upper triangular matrix because above the main diagonal we've got numbers other than 0. Everything's above the main diagonal. And below we've got that 1s and 0s look. Now think about what that means. Think about how we went from here to here. We just took the numbers in front of x, y, and z and plugged them in on this side. We took the constants on the right side of the equals and plugged them in here. Well, this means the same thing. This means the same thing as the original. It's just got these 1s and 0s now. So this REF form of the matrix, the top row, the 1, 1, 1, 2, 19, means 1x plus 1y plus 2z equals 19. The 0, 1, 2, 13 on the middle row means 0x is 1y, 2z equals 13. And the bottom row, 0, 0, 1, 5, means 0x is 0y is 1z equals 5, or equivalently just z equals 5. So we've solved for z. We know that z, that's part of the solution, z equals 5. Well, if z equals 5, the previous equation has a z and a y in it, but no x's. So since I know z equals 5, I can rewrite the middle equation, y plus 2 times 5 equals 13, which is y plus 10 equals 13, which I can easily subtract 10 from both sides and get y equals 3. All right, and then finally I know y and z, and I plug back into the top equation. I'm going to replace the y with 3 and the z with 5. X plus 1 times 3 plus 2 times 5, and I can change that to x plus 3 plus 10, which 3 plus 10 is 13, and then subtracting 13 from both sides, and I get x equals 6, y equals 3, z equals 5. So my solution would then be 6, 3, 5, written that way as an ordered triple. Alright, but again, just notice the work that we did. We made the augmented matrix. We got a 1 in the first upper left corner by row swapping. After we did that, we multiplied the top row and added down to the second and then third rows to get the zeros in that position. We then, well, because we noticed the sign difference here, we went ahead and added to get a 0 in this position. But typically, you go ahead and divide that middle number right there to get it to be a 1. All right, and then normally you add down. But if they're opposites like that, it's fine to go ahead and add them together to get a 0 there, then deal with that number. But then finally, the last thing you do is to get this to be a 1. So we multiply by a fourth, negative a fourth. We got a 1 there. So 1's on the main diagonal, 0's below that, and then work backwards. Work through that backwards to get z, then x, the y, then x. All right, let's check it. We got this is our original matrix, or this is the matrix after I swapped rows. But still, either way, you can put it in the original or this one. But I've got this one in as the original matrix. I'm going to RREF it just to show you that we do get the same thing. So I'm going to check it with RREF. So RREF matrix B, all right, and I get the 635, which is what we got as our answer. Okay, so the work's fine. We just use to get the zeros on the below the main diagonal is just a quicker way than to have to get zeros below and above. You can get zeros above doing the same thing that we've been doing. It's just a longer process. We are going to do one of these later on, but just know that REF, the REF form, will give you the zeros below it. All right, same thing here. I'm going to set up a system of matrices to solve this one. I'm going to go through this one a little bit quicker. All right, so here's my original augmented matrix. Same thing I'm going to do last time. I need a 1 in this upper left position. These other two rows have 1s there, so I'm just going to do a simple row swap to get things started. So I'm going to move the second row up to the top, move the original top row to the middle, and that's going to be my first change to the matrix I get, just to get that 1 there. Okay, and now I'm going to do row 1 times negative 2 and add it to row 2. All right, negative 2 times row 1 plus row 2. Okay, again, you can do it on your calculator. I get 0, 3, negative 2, 0. So that's what's there. And then I'm going to do the same thing, but this time I'm going to do it to row 3. So 1 and 1, I need a 0 here. So I need to do negative 1 times row 1 plus row 3. Again, don't forget your calculator. Second enter. The last thing we did was something similar. So I'm going to go up here and change that from a negative 2 to a negative 1 times row 1. I didn't change anything. Row 1 is still the same. And then row 3, I'm going to change to this bottom row here. So 1, 2, negative 1, 6. All right, bracket's still there. So 0, 3, negative 3, negative 3. So 0, 3, negative 3, negative 3. So there's my new row 3. Always replace whatever row you're adding down to. So there's my new row. I got the 1, 0, 0 there. All right, these aren't opposites this time, so I'm going to go ahead and divide to get the 1 here. So I'm going to do 1/3 of the second row. All right, the original row, or the previous row 2 was 0, 3, negative 2, 0. If I divide that by 3, I get 0. 3 divided by 3 is 1. Negative 2 divided by 3 is negative 2/3. And then 0 divided by 3 is 0. So there's my new row 2. All right, I've got 0, 0, and now that 1 there, I need to get a 0 here. So I'm going to multiply the top row, the middle row by negative 3 and add it down. Now, notice if I multiply the top row, by 3 and add down, I'll get a 0 here, but I'll get a 3 right here. So I don't ever work back with this top row again once I have zeros here. Now that I have a 1 here, I'm only going to work with the second row to get a 0 in that position. So negative 3 times the top row, second row, and add down. All right, again, I'm doing negative 3 times row 2 plus row 3. So negative 3 times row 2 is 0, 1, negative 2/3, 0, plus row 3 is 0, 3, negative 3, negative 3. All right, I'm going to hit enter. Then I'm going to have 2 zeros, a negative 1, and a negative 3. So I'm going to replace the old row 3 with this. All right, then the last thing, we want this last bottom right corner to be a positive 1. Sorry, it's a negative 1 right now. So to make it a positive 1, I'm going to divide or multiply, whichever one you call it, this bottom row by -1. Alright, so there's my last matrix. I've got the ones on the main diagonal, the zeros below the main diagonal. So that means I'm ready to go. This tells me right here z equals 3. So y minus 2/3 times z, so that's y minus 2/3 times 3. Well, 2/3 times 3 is just 2. So I get y minus 2 equals 0. Add 2 to both sides, and you get y equals 2. And now I have z and y, and I'm ready to go into the top equation and solve. So x minus y, that's x minus 2, plus 2 times z, that's 2 times 3, equals 9. So then I simplify. That's x minus 2 plus 6, and then -2 plus 6 is 4, and then subtract 4 from both sides, and I get x equals 5. So 5, 2, and 3 is the solution here. Alright, and then again I can go back up and check it with the calculator. Alright, so I've got it in there. Back out, come back in, RREF to get your solution. Alright, and then come back and call matrix. So 5, 2, 3, there's our answer. So it coincides with what we got there doing that. Now, you may be wondering, why would I do all this? Well, the nice thing about matrix operations and going through and solving your system this way with these matrix operations is there's not a bit of algebra going on. Once you get the matrix set up, the original augmented matrix set up, and then maybe do a row swap to get a 1 right here, all you're doing is arithmetic. It's just multiplication and addition all the way through here until you get to the very end. Right? The only algebra you do is right here at the very end when you plug in this into this equation and then solve, and that number and this number into the top equation. It's just the various tiniest little bit of algebra right at the very end, and the rest of it is 100% arithmetic. So you get to actually solve a linear system using only arithmetic. Alright, now when you do your final exam, I'm going to give you a system, a 3x3 system like this, x, y, and z to solve for. And it's going to be a long blank piece of paper, and it's going to say solve this system by hand or any method you choose. And the methods that you're allowed to choose are addition or substitution like we did in chapter 7. You can use this RREF form showing all the different matrices that you come up with all the way, or another method that we're going to talk about later on in chapter 8 called Cramer's rule, and those are the methods you're going to be allowed to pick from. Okay, but you're not allowed to just RREF the matrix. Okay, you have to be able to do something by hand, and this is one of those things that you can do. Again, the nice thing about this is 100% arithmetic.